Alright, I've got a lot going on with this cosine graph, so let's start by breaking it apart and figuring out what each piece of this does. Notice that this does include a phase shift. That was the new aspect we haven't taken a look at before. So, a few things that I want to note about this. I can see that the amplitude is going to be 2, that's my a value. Also, since that a value is negative, I'm noting that this graph has been reflected, so the cosine will be reflected of what we're normally used to seeing. I have this plus 1 at the end, so I know my midline is going to be shifted up 1. And then finally, the two really important parts I need actually to start this problem, I need to know what the period is, and I need to know what the phase shift as well is. So the period we'll find the same way we've always found the period of a cosine graph. That's 2 pi, the normal period, divided by the b value, which this time is 4. So simplifying that, I get a period of pi over 2. And then finally, the new aspect of this is that phase shift, the number being added or subtracted to the x value. To find the phase shift, it's first of all the opposite of the number you see there. So negative 3 pi in this case, divided by the b value, which is 4. So my graph is actually going to be, every single point is going to be moved to the left 3 pi over 4 spaces. Because, again, I want to change that sign like we've always done for the horizontal shift. So that's everything I need to know about this graph to start sketching it. To begin the phase shifted graph, I'm actually going to begin with sort of a rough sketch of what this would look like a rough draft. And if you watched the last video, this is nothing new to you. So normally my x-axis would be labeled from 0 to the end of the period, which is pi over 2. And then I would go ahead and add the halfway point, which would be pi over 4. I'd add half of the halfway point, which is pi over 8. And then 3/4 of the way, which would be 3 pi over 8 in this case. So that's where my points would normally be for one period of this graph. But remember, I've phase shifted or horizontally shifted these points negative 3 pi over 4 to the left. So what I need to do is take all 5 of those values and subtract 3/4 pi from each one to get my new graph. So to do that, I would recommend just using a calculator, especially if you don't want to have to worry about all those common denominators for the fractions. The first one's easy though. Of course, 0 minus 3 pi over 4 is just going to be negative 3 pi over 4. And then continue on in using a calculator, 1 pi over 8 minus 3/4 pi would be negative 5 pi over 8. And what I'd recommend you do if you're using a calculator is don't actually type the pi symbol in. Just for example, for this next point, do 1/4 minus 3/4 and put the pi back on it. So that would leave me at negative pi over 2. And then continuing on, I'm just going to assume you guys know how to do this or can pause the video and try it on your own. Next up would be 3 pi over 8, and then finally I'd have negative pi over 4. So that's where the new 5 points are located. Now what I want to do before I actually graph this is I want to indicate where the x-axis, or I'm sorry, where the y-axis would be located. I can see that my points are getting bigger as I go to the right. Of course, that's how they go. So eventually, if I keep going to the right, I'm going to hit the y-axis. And so, or I'm sorry, the x-axis. No, I was right the first time, the y-axis. Sorry. So I know it's going to be somewhere over here, and I could be more accurate if I want to, but I don't really want to. So I'm just going to include this symbol, which is kind of like a break in the graph, and say eventually I'm going to get to the y-axis. Okay, if you want to be more accurate, then just keep this pattern going, and you can figure out exactly where that would hit. But for our purposes, I don't really care. So at this point, I'm going to finish the graph like I always would. So I'm going to move my midline up 1. So my midline has been shifted up 1. And then I'll include that midline going across my graph. Using the amplitude then, an amplitude of 2, I'm going to count up 2 spaces. So 3 will be a significant point on my graph, and I'll count down 2 spaces, so 1. Negative 1 would be a significant point as well. So at this point, I'm now able to graph my one period of the cosine graph. So remember, we're always starting from the left. So even though my graph is sort of to the left of the axis, I'm still going to start from the left and then work my way right. So I have a reflected cosine graph, recall. So reflected cosine graphs are going to begin from the low point. So I have to kind of draw over my numbers, which I don't like to do, but oh well, it's the way it works. From there, it's going to go to the midline. The next point would then be at the high end of my graph, so at 3. Next point would be back to the midline, and then I'd end back where, or I'd end at the low point, back where I started. So again, drawing over my numbers. So I'm going to use those to then graph my cosine. Remember, it curls at the end, so I'm going to kind of start early. I'll go up through those points, I'll come back down, and then I'll kind of go back up a little bit. And remember, these graphs go forever in both directions. So there's one period, that original period, which now has been shifted to the left. If I wanted to be more accurate, I could figure out where this wave would eventually hit the y-axis. But like I said, for our purposes, I don't really care. I just want to be able to see one period of that, and there It is.